You know, when we ask an AI a question, we really only care about one thing, right? Did it get the right answer? Well, what if focusing only on that final answer is making us miss a much bigger and honestly way more important story? Okay, let's get into this, because we're going to look past the answer and peek inside the mind of an AI.
So this is the big question for today. Is it possible for a machine to look like a genius on the outside while its actual thought process is just a total mess? And spoiler alert, the answer is a huge yes, and it changes everything about how we should be thinking about AI.
Okay, get this. This is a real example from the research. An AI was asked a simple question: who won the first celebrity Big Brother? And boom, it finds the perfect answer. A clear source says the comedian Jiaqi won. Done deal, right? Nope. The AI literally ignores this perfect piece of evidence. It says something like, I need to clarify which Big Brother, and then goes on this totally useless detour doing a bunch of other searches. And then, after all that nonsense, it gives the correct answer, Jiaqi. It got there in the end, but its whole process was just completely backwards and illogical.
So that whole Jiaqi situation, it's the perfect example of this massive blind spot in how we test AI. We've been giving them a gold star for getting the answer right without ever, checking their work.
This is really the heart of it. We're seeing this major shift in thinking. The old way was super simple. Is the AI's final answer correct? Yes or no? But the new way, the way these researchers are pushing for, is all about the process. How did the AI get to that answer? Was its reasoning any good? Did it even use the evidence it found? We're moving from just grading the destination to actually mapping out the entire journey.
So why does this matter so much? Well, because understanding that journey, that process, is the only way we're ever going to build AI that we can actually trust.
I love this analogy because it's so perfect. Judging an AI just on its final answer is exactly like a math teacher who only looks at the number you wrote in the final answer box. I mean, you could have guessed, you could have copied from your neighbor, you could have made two mistakes that somehow canceled each other out, and you'd still get full credit. But would you have actually understood the problem? No way. That's where we are with AI. We're missing the how.
To fix this, the researchers are talking about a new gold standard. It's called Epistemic Competence. I know it's a fancy term, but it boils down to a pretty simple idea. How good is an AI at thinking? Not just remembering facts, but actually finding, judging, and then using information in a way that actually makes sense. This is the quality we really need to start measuring.
So how in the world do you grade an AI on thinking? Well, the folks at SeekBench broke it down into 3 core skills. Think of it like a report card for an AI's brain. First up on the report card is groundedness. This goes right back to that Jiaqi example. Is what the AI is saying actually backed up by the information it found, or is it just kind of making stuff up to get to the answer? A high score in groundedness means the AI's logic is actually tied to reality. Next subject, recovery. What happens when a search query comes up empty? A not-so-smart agent might just keep trying the same failed search again and again. But a smart one? It recognizes it hit a wall, it adapts, and it tries a whole new way of asking the question. It's all about being resilient and a good problem solver. And the final subject is calibration. And this one's all about self-awareness. Basically, does the AI know what it knows? A well-calibrated AI won't give you an answer unless it's pretty darn sure it has solid evidence. It doesn't guess, it doesn't just take a shot in the dark, it knows when to say, I don't know.
All right, so we've got this new report card. The researchers put a bunch of the top AI agents to the test with it, and what they found, well, it completely flips the script on which models we thought were the smartest.
So, if you grade these AIs the old way, just on final answer accuracy, the models that were trained using something called reinforcement learning, or RL, they look like the valedictorians. They're at the top of the leaderboard. They get the right answer more often than anyone else. Simple as that.
But then, here comes the plot twist. When you grade them on groundedness, on how good their actual reasoning is, the results get turned completely upside down. The model with the best, most logical reasoning is actually one that was near the bottom for accuracy. And all those so-called smart RL agents, their reasoning quality is actually worse. They are literally getting the right answer for the wrong reasons.
And this quote from the paper just nails it. The very training technique we've been using to make AIs more accurate is, at the same time, making them worse thinkers. It's teaching them to win the game, to get the right answer no matter what, even if it means throwing logic and evidence right out the window. But hold on, the story gets even more interesting. It turns out reinforcement learning isn't a total villain. It might mess up an AI's reasoning, but it's amazing at teaching it that third skill on our report card, calibration.
I mean, just look at these numbers. The overconfident answering rate. That's how often an AI gives an answer when it really doesn't have the goods to back it up. It just plummets for the RL-trained models. It drops from over 63% all the way down to 35%. So, yeah, their reasoning might be a bit shaky, but they're much, much better at knowing when to just keep quiet.
So this whole discovery that different AIs have these very different specialized skills led the researchers to this really cool final idea. What if we stop trying to build one single super AI, and instead we build a team of specialists?
The idea is actually pretty simple, but it's so powerful. You take one AI that's a rock star at digging up information, and you have it do all the searching. Then you just hand all that evidence over to a totally different AI, one that's great at making sense of information, and let it come up with the final answer. You just combine their strengths.
And the results? They were just wild. The best model at putting it all together saw its accuracy score jump by 3.5 points when it was given the evidence gathered by the so-called worst model, the one with the lowest accuracy score on its own. This proves that the worst model was secretly an amazing researcher, a skill that was totally invisible when we were only looking at its final answers.
So, what's the big takeaway here? What does this all mean for the future? Well, it means we finally have a new way of looking at things, a roadmap for building AI that isn't just correct, but is also reliable, understandable, and, actually trustworthy.
At the end of the day, why does this matter? Well, for one, AI safety. If we can see flawed reasoning, we can fix it before it causes a real problem. It gives us better interpretability. We can actually understand why an AI is saying what it's saying. It also points us toward designing smarter modular systems where different AIs do what they're best at. But most importantly, it forces all of us to finally move beyond just caring about that final simple answer.
And that really leaves us with this final critical question to chew on. In really high-stakes situations like medicine or finance, if an AI gives you the right diagnosis or the right stock pick, but its reasoning for getting there is a complete black box of weird leaps and ignored facts, does that right answer even matter?